Hi, this is Professor Sartor, and I'm going to be working a few more problems related to exponential and logarithmic functions. This question says, use the properties of logarithms and the logarithm property of equality to solve the logarithmic equation. Let's focus on this logarithmic property of equality. What this property says is if you have the situation where you have log base b of m equals log base b of n, focusing on the details here, we have an equation in which on both sides we have a log with the same base. So if we have this situation, this property tells us that what's inside the logs must be equal to each other. So therefore m must equal n. If we look at the problem that we were given, log base 3 of 2x plus 3 equals log base 3 of 13, we have exactly that situation where we have an equation, and on both sides of that equation we have log base 3 and log base 3. And so this property tells us that what's inside the logs must be equal to each other. So this property allows us to simplify the equation. So we started off with log base 3 of 2x plus 3 equals log base 3 of 13. And that property says that what's inside the log on the left has to equal what's inside the log on the right, giving you a simpler equation that doesn't have logs in it. Then we're going to solve this equation by getting x by itself. So we'll subtract 3. That gives me 2x equals 10. We'll divide both sides by 2, and we get x equals 5. Every time you solve a log equation, you must check your work. And that's because log equations have domain restrictions. You can only take the log of positive values. So we need to make sure that when we substitute that x equals 5 into our equation, that we're going to get log of a positive value. So I'm substituting the 5 in for x, and simplifying, that gives me 10 plus 3 and log base 3 of 13. So as long as what's inside my log comes out to be a positive value, I'm going to keep that solution of x equals 5. If I get a negative value inside the log, then I have to throw that solution away.